Assalamualaikum. Okay, I would like to discuss on the continuous beam analysis using moment distribution method, and this is a three-member beam. It is A, B, B, C, and C, D. They are three members. Okay, A is fixed, B and C roller, and D is cantilever N. Okay, this beam has an external moment at B, 15 kN meter clockwise, and there is a triangular load along member CD and a point load at D. Okay, before we start, just to refresh back. Okay, normally 3 members means 3 times 2. 3 members means there are 6 member and moment. However, for N cantilever, just like D, since D is cantilever, no moment. There is no moment at D, so we have to minus 1. So the member and moment in this beam is MAB, MBA, MBC, MCB, and MCD. There is only 5. Okay. Just to highlight some important thing here. Number 1, please remember that the first moment in the table is we get from FEM, and this is actually the first member and moment in the table. Okay, and for cantilever N, the first member and moment will be determined using equilibrium equation for cantilever N. Okay, for cantilever N like this. Alright. Okay, please remember that we are actually distribute joint moment, not member and moment. And joint moment is opposite with member and moment. Okay, please remember this. Okay, so I want to highlight 2 joint here, joint B and joint C. Okay, this is joint B. At joint B, this is the diagram for joint B. Okay, so this is joint B. Okay, so the joint moment for B is this one. Okay, this is the joint moment. Okay, and since there is no FEM at AB, at member AB, and there is no FEM at member BC, the value is 0. So joint moment in at joint B is 15. Okay, for joint C, there is no fixed end moment at member BC. However, there is a value of MCD which we can get from a triangular load and a joint moment, and we need to calculate the value of MCD using equilibrium equation. Okay, it is like this. Okay, this is 20, this is 6, this is 3 meter. Okay, so this is C and D. So there is no C and D. There is no moment at D. Okay, there is only moment at C. This is MCD. Okay, so by using equilibrium condition, MC is equal to 0. So we solve this using the concept that we have learned in solid mechanics, calculate reaction. Okay, but this is internal moment. Okay, this is MCD, it is positive, plus for triangular load, the force is equal to the area. So the area is 1/2 times 3 times 6. Okay, the length is, the centroid is 1/3 1/3 times with length is 3. Okay, we plus with 20 times 3, and this is equal to 0. So MCD is equal to negative 69 kilonewton meter. Okay, so MCD is negative 69. Okay, so now we will start doing moment distribution. Okay. AB, BA, BC, CB, CD. So this is member. Okay, okay, this is join. Member. It is okay. We need to determine K in order to determine DF, and K is in terms of EI. Okay, then DF, then the first member and moment we put under FEM, the first moment in the table. Okay, but this time because of joint moment, applied moment, there is an applied moment that is applied into at joint B, so it is joint moment. So here carry over. Okay, distribution, carry over, distribution, okay. So we have member A, B, it is BA, BC, CB, and CD. CD. Okay, so this is join A, join A, join B, and join C. Okay, K value, it is 4EI over L is 2. 4EI over L 2. This is 4EI over L. Okay, we don't need to calculate EI for N cantilever, for member with N cantilever. So DF is 0 for fixed and 0 also for CD. Why CD is 0? Because CD has moment. Okay, same condition with fixed which has moment. Okay, so the rest is 0.5. 0.5, and here is 1. Okay, for the first fixed end moment, it is negative 69 here. 69. Okay, and join moment 15 at B. 15. This is join moment 15 at B, and positive 69 at C. Okay, so for distribution, it is 15 times 0.5, it is 7.5. 7.5. 7.5. Okay, 69 times 1 is 69. Okay, then we carry the value by times with the factor. Carry the value. Okay, 7.5 it is 3.75. 3.75. And 34.5. Okay, continue distribution. 17.25. And for CB, it is 3.75 times 1, it is negative 3.75. Okay, we continue carry over. it is 17.25 divided by 2, 8.625. Negative 8.625. Negative 8.625 is negative 1.875. Okay, so 1.875 is positive 0.938. 0.938. Okay, so okay, we continue. The last is distribution. Continue with carryover. CO. So it is 0.938 divided by 2, 469. 0.469 0.469 and okay, here is I miss one thing. This is 8.625. Carry the value 8.625 divided by 2. It is okay, all is positive. This is 4.313. Distribution, it is 4.313 times 0.5. It is negative 2.157. Negative 2.157, and this one is negative 0.469. Okay, continue back with carryover. So carryover, we bring the value like this. It is 2.157 divided by 2. It is remain the sign 1.079 negative 1.079 0.469 divided by 2 is negative 0.235. Okay, continue with distribution. Continue with distribution. It is 0.235 times 0.5. It is positive 0.118. It is 0.118, and this one is 1.079. This is distribution. Okay, continue with carryover. Carry over, and again like this. Okay, it is 0.118 divided by 2. It is 0.059. 0.059. 0.059. 1.079 divided by 2. It is 0.54. Okay, we continue with distribution. Another distribution. It is negative 0.27. Negative 0.27. Negative 0.059. Okay, carry over.
Warna bekas. Warna bekas je.
0.27 divided by 2 is
Mana? Ini warna bekas.
negative 0.135. Negative 0.1. And 0.059 is negative 0.03. Okay, next is distribution. It is 0.03 times 0.5. 0.015. It is 0.015,
masuk.
and negative 0.135 times 1 is
Masuk.
0.135. So this will be the last distribution, and now it's the time to find the total moment.
Boleh duduk elok. Nanti kalau dia duduk bilik saya pun ada kunci. Katanya duduk ibu. Ada duduk.
Okay, okay, now is the time to calculate the member end moment. Okay, start with this one. For AB, start with 3.75. 3.75 minus 8.625
Hantu mama itu.
plus 0.469 minus 1.079 plus 0.059 minus 0.135. Total is negative 5.5.
Ibu dia tak boleh kulak.
Negative 5.561. Okay, for BA, we will start with 7.5. 7.5 minus 17.25 plus 0.938. Continue with this, minus 2.157 plus 0.118 minus 0.27 plus 0.115
Jangan pergi mana-mana.
is
Tak boleh nanti hantu mak.
negative 11.106. Okay, for BC, we start with 7.5. It is 7.5 plus 34.5 minus 17.25 minus 1.875 plus 0.938. Continue with this, plus 4.313 minus 2.157 minus 0.235 plus 0.118 plus 0.54 minus 0.27 minus 0.03 plus 0.015. It is 26.107. Okay, for CB, start with 69. Okay, and the answer is 69. 69. And for CD, it is start from the first moment in the table. For CD is negative 69. So total is negative 69. it is negative 69. Okay, so we may check the answer. So here MAB is negative 5.561. MBA is negative 11.106. MBC is 26.107. MCB is 69 and MCD is negative 69. So we can check MBA is equal to MB is equal to MBA plus MBC. It is equal to negative 11.106 plus 26.107, and this is equal to 15. And MC is equal to MCB plus MCD. This is equal to 69 minus 69 and equal to 0. Okay. So there are 5, as I mentioned earlier, there are 5 end moment for this beam because ND is cantilever. So the moment is MAB negative 5.561, MBA is negative 11.106, MBC is 26.107, MCB is 69, and MCD is negative 69. Okay, so having this value, we can actually draw the bending moment diagram. Okay, for the bending moment diagram, so this is the moment. Okay, for the bending moment diagram, so the sign that we can see here is actually the moment rotation. So we have 3 member. For AB, it is negative moment. For MBA, BA is also negative. Okay, MBC is positive. MCB is positive, and MCD is negative. Again, MAB is negative, MBA is negative, MBC is positive, MCB is positive, and MCD is negative. So from this we can identify the position. Okay, the diagram look like this. Okay, for AB, the point is right here. Here is the point. Okay, and it is MBA is 11.6. Okay, MBC 26, MCB is 69, okay, and 69, Okay, for triangular load, S shape. Okay, so the value is here is 5.561. This is 11.106. This is 26.107. Okay, and this is 69. So the first value is negative. This is negative. This is positive. This is negative. So this is the bending moment diagram. Okay. Okay, we analyze a continuous beam ABCD. This continuous beam has an cantilever at D. Okay, and there is also an external loading, external moment apply at B, 15 kN clockwise. Okay, member CD has a triangular load. Okay, step number, and we must know some important things here. Number one, in this beam there are only 5 member end moment because we have to minus 1 for cantilever end. Okay, and in the table, please remember that the process that we actually do is to determine the moment value at distribution level is we actually distribute joint moment, not member end moment, and joint moment is opposite with member end moment. Okay, I just want to highlight these two joint A and at joint B. At joint B, there is no MBA and MBC because member AB and member BC has no fixed end moment. However, at joint B, there is a joint moment or external moment that is applied into B. Okay, so we actually analyzing joint like this. Okay, like this. And at joint C, what is actually happen? Joint C get the joint moment from the MCD, and we calculate the value of MCD using equilibrium equation, not the fixed end moment. Okay, so this is how we determine the value of MCD as the first member end moment value in the table. So it is by we apply equilibrium equation. It is MCD plus, okay, moment is P times L. P is force. So a triangular load means force is equal to the area. So the area is 1/2 times 3 times 6, and length is 1/3 over 3. Okay, and plus we need to plus with P is 20, length is 3. So we get negative 69. So we start make a table. So DF is 0, 0.5, 0.5. And for CD, since at joint D, there is a moment. So now the properties of D is equal to fixed end, where fixed end has moment. So we have to put 0 for the distribution factor. And since I said that previously in class, the total moment, the total DF at joint must equal to 1. So at CC is actually pin or roller support. Okay, so total must be 1. So it is 1 plus 0 is equal to 1. Okay. So the first member end moment is 69 here, 69. And since there is a joint moment, so I put another row for joint moment. Okay, the joint moment is 15, and joint moment for C is 69, opposite with negative 69. And remember, when we find the joint moment, what we need to do is joint moment times with distribution factor without changing any sign. Okay, so for distribution, it is 15 times 0.5. 0.5 it is 7.5 and 7.5, and 69 times 1 is equal to 69. So we carry the value to B to A, B to C, okay, and C to B. Alright, we get like this. Okay, 7.5 divided by 2, it is 3.75 at AB as well as at CB. Okay, and 69 divided by 2 or times 0.5, it is 34.5. And then we continue the distribution process. So this is member and moment, so we continue, means that we need to change back the sign in order to show the opposite condition. So total moment is 0 plus 34.5, it is negative 34, times 0.5, it is negative 12.25. And for CB, it is negative, it is 3.75. The opposite is negative, negative times 1, so we get negative 3.75. Okay, then we repeat again the distribution process. We carry to the to opposite joint. Okay, and then we repeat again distribution. Okay, we do the same process repeatedly until the moment reaches 0, like this. Okay, and please remember that we must stop at distribution. We cannot stop the table at carryover. We must stop at distribution in order to balance all the moment. Okay, so we get this moment. Okay, negative, negative, positive, positive, negative. So this is actually the moment direction. So this moment direction we transfer into the diagram. So this is negative, negative, and positive, positive, and MCD is negative. So from this as our guide, so we should draw the bending moment diagram, as you can see here. Okay, thank you very much. So you may try this to get more understand. Okay, kena practice lah. Okay, so that you can understand this more. Alright, thank you very much for watching this. Assalamualaikum warahmatullahi wabarakatuh.